Welcome viewers, in this video we will see the details about Tellegen's theorem. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. The explanation of Tellegen's theorem, one of the theorem available in the circuit theory. First we will see the statement. In any network, the summation of instantaneous power or the summation of complex power of sinusoidal sources is 0. So if you consider any network, sum of the instantaneous power or complex power is equal to 0. The network may be linear, non-linear, passive or active and time invariant or varying, whatever may be. Either there is linear or non-linear, passive, active, time invariant or varying, the instantaneous power is 0. For instantaneous power, the theorem may be expressed mathematically as summation of B equal to 1 to B, VB, IB equal to 0. This B into I is nothing but power. Power equal to voltage into current. B is nothing but starting from 1 to B for n number of powers. Or if you add all the power in the network, that is equal to 0. That is the statement. In case of the complex power, the expression will be different. In case of complex power, where B is the number of branches in the network. For example, for complex power, the theorem may be expressed as B equal to 1 to B, SB equal to 0. What is that? SB is nothing but VB into IB star. That IB star is the complex conjugate of IB. Complex number means automatically we have real term and imaginary term. So that the star refers the complex conjugate of the IB. So in any network, the sum of the instantaneous power or complex power is equal to 0. This B equal to 1 to B means n number of networks, n number of branches. Right. The some more details available. We'll see the some more details available in the Tellegen's theorem. The above statement implies that energy must be supplied at the rate which is just equal to the rate at which energy is dissipated in resistor and stored in capacitor and inductor. So that is the meaning energy. What is the energy supplied is equal to energy dissipated. Energy dissipated means is dissipated in resistor. In case of capacitor inductor, energy is stored. So what is the energy rate supplied? That is dissipated in case of resistor, capacitor and inductor. So energy supplied is equal to energy dissipated. So that we are getting net power is 0. Thus the power delivered by independent source of the network must be equal to the sum of power observed in all other branches of the network, either dissipated or stored. So we need to understand that power delivered by the independent source of the network is equal to sum of power observed in all other branches of the network. Right? What is the power observed? That should be equal to power delivered, so that we can get the net power is equal to 0. Right? One important note is available. The branch voltages are arbitrary chosen with the only constraint that they satisfied KVL, Kirchhoff's voltage law. Right? So the net power in all the branches is 0. We are taking that this branches should satisfy the KVL. The branch current are also arbitrarily chosen with only the requirement that they are satisfy KCL, Kirchhoff's current law at each node. So this theorem states the instantaneous power or complex power is 0 in any network, whether it is time varying or invariant, linear or non-linear, passive or active, either it is normal power or complex power, the instantaneous power is 0, provided that it should satisfy the Kirchhoff's voltage law, branch voltages. Similarly, the node voltage, node or satisfy the Kirchhoff's current law, KCL, KVL and KCL. It should choose, you have to satisfy KVL or KCL, then only this statement is true. So in this video, we discuss about the details of Tellegen's theorem, statement of the theorem, mathematical expression and important points, that is power observed equal to power dissipated. in they either by resistor, capacitor or inductor. Similarly, power what we delivered should be equal to the power absorbed by all other elements, and also it should satisfy the KVL or KCL, Kirchhoff's voltage law or Kirchhoff's current law. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.